And today we are going to cover the last section of Chapter 2, Section 2.5, Survey Problems. Before we start the lecture, I want to remind you, so you cannot hear? Yes, Angie, please rejoin. So I want to remind you, today is January 29. We have two chapters, Chapter 1 and Chapter 2, and Quiz 1. Those assignments due on January 31st. Okay, the end of this month. You have assignments due the end of the month. Be aware of that. All right. So let me get the notes. The last section of Chapter 5, Survey Problems. And we're going to work on the problems in the guided note to warm up. We remember what is the Venn diagram, right? Venn diagram always have a box. Always have a box. The box represents the universal set. Circles inside the box represent sets. Look at this Venn diagram. We have a box, which is a U, and we have three circles. They are circle A, B, and C. Represent the set A, set B, and set C. And those three sets overlap. So you can see the darkest area is the intersection of all the three sets, right? And we also see the numbers in the box. We see 8 here, 10, 2, 7, 3, 6, 1, 5. What are those numbers? You know, what those numbers represent? Are those numbers elements? Sometimes we put the numbers in the Venn diagram and they are elements. But sometimes, especially when we are talking about a survey problem, those numbers very likely represent the cardinal number of the region or cardinality of the region. How do we know? The problem tells us, okay? The problem tells us right here. Use the Venn diagram, which shows the cardinality of each region. The cardinality of each region. That's how do we know those numbers 5, 1, 6, 2, 7, 3, 10, 8. Those numbers are not elements in the sets. They are cardinalities of regions in this diagram. For example, the 5 here is the cardinal number or cardinality of this pink region. All right? That's what it means. That means there are 5 elements in this region, in this pink region. 5 here is not an element. 5 here is the cardinality of that region. Similarly, there are 6 elements in this region. Actually, I have the writing board. Let me use my stylus, make it easier. And the yellow region has number 6 in it, right? 6 is not an element in the region. 6 is the cardinality of the yellow region. And also, let me take another color, let's say blue color. Ten here represents the cardinality of the blue region, all right? So as you can see, the 3 circles overlap. The 3 circles overlap. And the darkest region in the middle, they are the intersection of all the 3 sets. There's a number 7 in the region, and not 7 is the cardinality of that darkest region, and it means the 3 sets ABC, the 3 sets have 7 common elements. There are 7 elements in common for all the 3 sets. Let's see, do you have any question here? Angie, I'm here, can't see the board. Don't worry about. Oh, okay. I'm sorry about the tech issue.
I know. I'm sorry. I don't know what's going on. But I'm
no.
listening. I have my stuff opening out.
Yeah, I'm recording also, so you can watch the recording afterwards.
Thank you.
Hi, Emerson. In the future, if you missed the roll calling, remember to email me. Then I can fix your attendance. I'm not going to, fix it in the middle of teaching. Please remember to shoot me an email, and I'll fix your attendance. If you don't email me, then your attendance will be compromised. All right. Let's continue. So yeah, I'm trying to say this region. I'm using a black color to frame it, to highlight the boundary. And that region is the intersection of all the 3 sets. There's a number 7 there. That means the 3 sets have 7 common elements. We have 7 elements belong to all the 3 sets. Use a different color. This region, and this region, I'm using a orange or red color to frame the 3 regions. And see the 3 regions as the petal. You see the flower. See the 3 regions as the petals of the flower. And the darkest region in the middle is the center of the flower. So you're looking at a flower with 3 petals. In this petal, in this region, we have 1 element. Here we have 2 elements. Here we have 3 elements. So that's how do we understand the numbers in the Venn diagram that is about a survey problem. And we are going to answer the questions based on the information from the Venn diagram. The first question, how many elements belong to set A? How many elements belong to set A? Set A is represented by the circle A here. All right, we need to find out the cardinality of set A. Means we need to figure out how many elements in the circle. How many elements in the circle? How do we do that? How do we know? Very good. Thank you, Jack. It is 15. Perfect. How do we know it's 15? Because I'm going to use a very strong red color. Just count how many elements in this circle, right? That circle represents set A. But the cardinality is not 4. It's not that you see 5, 1, 2, 7. They are not elements. Again, they are not elements. This red circle, based on the Venn diagram, is divided into 4 regions. The region pink, the darkest region, the center region, and 2 petals, right? We just need to add up the cardinalities of those 4 regions. Then we would have the cardinality for this circle, which represents set A. And we have 5 elements in the pink region. We have 1 element in this region, 2 here, 7 elements in the center region. And we add them together, 15, right? 2 plus 7 plus 1 is 10, 10 plus 5 is 15. That's how do we understand the question, all right? Yeah, I'm gonna erase the very strong circle. And here we're supposed to have pink color. Restore this. That's the first question. Second question, how many elements belong to set B but not set A? Oh, I read this wrong. It's not here. I'm going to label this as a question 1. 15 elements in set A. This is question 2. Okay, we're on question 2. How many elements belong to B but not A? Well, we want to know the region first and then figure out the number of elements in the region, right? Okay, belong to set A but belong to B but not A. Let's see, how do we express that set, graphically? Belong to B but not A. Do you agree this region represents the set of all the elements belong to B but not A? Do you agree? The color is pretty obvious, right? Very thick red color. Do you have a 9? Yeah, very good. So how many elements in it, guys? How many elements in that region? Yeah, you have 6 here in the yellow. You have 3 here in the paddle. Perfect, exactly. 9 elements. Perfect. You guys understand that very fast. So question number 2. We have 9 elements belong to B but not A. Third part is asking how many elements belong to A or B. Okay, we learned the set operations last time. We understand or here is inclusive or, right? A or B represents the union of the two sets, A or B. Let me trace the boundary of the region that represents A or B. A or B. Right? Okay, just count it. How many elements in A or B? 5 here, 1 here, 6 here, 3 here, 7 here, 2 here. Yeah, let's see, how do I add them up? If I add them up, I have 12 plus 7, 12 plus 12, 24. Am I right? Yeah, 24 elements. Just to simply add those numbers together. Add those cardinalities together. Perfect. 24. If you don't see it, please let me know. The fourth question. Let me erase this. Okay. It's yellow. Okay. So number 4. How many elements belong to A and B? A and B. The logic connective is and. And means both, right? Elements belong to A and B are elements shared by AB, or the common elements of the two sets. Graphically, in the Venn diagram, it is represented by this football-shaped region, right? A and B, the common region, the overlapping region. How many elements in that region? How many elements in that region? 8, right? Yeah, 1 there and 7 in the center. Oh, 8. It's not 2, Crystal. If you missed the beginning of the class, make sure you watch the beginning. I recorded the class. Those are not elements. Again, those are not elements. Sometimes they are. Depends on the problem. The problem will tell you what are those numbers represent. Especially when the problem is about survey, very likely those numbers are cardinalities, and the problem will tell you, will specify. Those numbers are not elements, they are cardinalities. So yes, we have 1 plus 7, 8 elements, right? 8 elements. Question number 4. We have 8 elements. Okay, I need 8 elements. Yeah, thank you, Ashlyn. Okay, very good. Perfect. Number 5. How many elements belong to A or C but not B? Which region in the Venn diagram represent the set of elements belong to A or C, but not B? I give you a little bit of time, okay? Yeah. So you should, on your scratch paper, you should have the diagram and you should do what I do. Draw the region, clarify which region we are talking about. A or C, but not B. A or C, but not B. A or C, but not B. Do you agree? I don't know how to describe the shape, but I use the very thick red color to highlight the boundary of that region, representing the set of elements belong to A or C, but not B. Do you see it? Do you have 17? Yes, you guys great. You guys great. Very good. I think 17, but you are right. You are right. Sorry, you are right, Crystal. Crescent moon shape. Actually, there's a like a pointing here. Go inside and then go out. It's not really, or two crescent moon together. There are 17. Yeah. Anyway, there are 17 elements, right? There are 17 elements. Perfect. You guys are doing great. The last one, question number 6, is asking, considering set ABC, how many elements belong to at least 2 of these sets? How many elements belong to at least 2 of the 3 sets? You know, there are different ways to process a problem, right? My understanding about number 6 is we are looking for the region representing the set of elements belong to at least 2 of these sets. At least 2, bigger than or equal to, has 2 situations, exactly equal to 2 and exactly equal to 3. Exactly equal to 3. At least 2 means exactly 2 or exactly 3, right? And look at our Venn diagram. The 3 petals, do you agree the 3 petals represent the region of, give me 1 second. Okay, so in a Venn diagram, the 3 petals, this petal, and this petal, they represent sets of elements belong to exactly 2 sets. For example, this part, this region, include the elements in A and B, but not C. In A and B only, not C. And here, the elements in this region belong to A and C, but not B. Only 2 sets, A and C, but not B. And this petal, the 3 elements, belong to B and C, but not A. So the elements in those 3 petals, they belong to exactly 2 sets of the 3 sets. And in the center, the 7 elements in the center, they belong to all the 3 sets, exactly 3. So the region we are looking for here, that representing all the elements belong to at least 2 sets of the 3 sets is this flower region, right? And we have a 7 in the middle, 1, 3, so 13. Do you have the answer 13? There are 13 elements. There are 13 elements belong to at least 2 sets of the 3 sets. Very good, perfect. You guys doing great. Perfect, awesome. Yeah, this is a warm-up problem. Just get used to identify the cardinalities for the regions. And how do we understand the Venn diagram? All right, let's continue. In a survey on musical tastes, respondents were asked, do you listen to classical or do you listen to jazz? The survey results are summarized in the Venn diagram below. Use it to answer the following questions. And give me a little bit of time. Give me a second. Let me fix the space between those questions. Then we can see everything just in the window. How many? Okay, a lot of questions. And that's it. Okay. Make sure that we see all the information. How many parts in this problem? We have part 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. Let's look at the Venn diagram. In the box, we have 2 circles. The circle on the left represents the respondents who listen to classical music. So you can see classical music, right? That's the circle on the left. The circle on the right is labeled as jazz. So the circle on the right represents the set of respondents who listen to jazz, right? And then the 2 sets overlap. That means there are respondents who listen to both, right? And then we have 30 right here inside the box, the universal set, but outside the 2 circles. So 30 here represents there are 30 respondents who listen to neither of the 2 type of music. They do not listen to classical, they do not listen to jazz either. Okay, again, those numbers are not elements. Those numbers are cardinalities. Okay, 30 here, as I mentioned earlier, represents the number of respondents who do not listen to either of the, music. Well, let's see if you can understand the Venn diagram and answer the question correctly. Number 1, how many respondents listen to classical music? Well, classical music, the respondents who listen to classical music is represented by that circle, the red one. How many people there? 55, or how many? Perfect. Yes, 75. Very good. What is 77, Levy? 77. Where does that come from? Is a typo? It's 75, right? Yeah, 75. Why we have 75? Because you have 55, you have 20. Basically, there are 55 respondents only listen to classical, but another 20 respondents listen to classical and jazz. But the respondents who listen to both still should be counted as people, who listen to classical, right? So add the 2 numbers together, 55 plus 20 is 75. There are 75 respondents, they listen to classical. Right? Is that clear, guys? 75. Perfect. Yeah. And the second question, we are going to figure out how many respondents listen to jazz. Jazz is represented by the circle on the right. Yeah. How many elements, how many respondents fall in that circle? You can see there are 2 regions, right? 20, 70. How do we understand those 2 numbers? 70 people only listen to jazz. 20 people listen to jazz and classical. But when you count the number of people who listen to jazz, you need to consider the people who listen to both, right? Yeah, they listen to more than one, but they do listen to jazz. So 20 plus 70, 90 is similar with earlier. 90 people listen to jazz. There are 90 elements in the circle on the right. I believe you get this right. Perfect. Good job. Very good. Third part, how many respondents listen to both classical music and jazz? Both, and intersection. Circle on the left, classical, circle on the right, jazz. Their overlapping part should be the people. Yes, very good. You guys are great. The overlapping people, the overlapping region, sorry. This overlapping region represents the respondents who listen to both. So we have 20 people who listen to both. Okay, the football shape region. Number 4, how many respondents listen to classical or jazz? Yeah, the logical connectivity is so important. Here is the and, here's the or, but that make one word difference will make a huge difference. Classical or jazz. So we are talking about the region. So we are talking about the union of the two sets. And this region represents the union of the two sets, right? 55 plus 20 plus 70, that is 90 plus 55 is 145. I believe you have the 145. Awesome. Huh? Did I calculate it wrong? Let me do it again. I'm sorry. So 20 plus 70, 90, right? Yeah, 90 plus 55, 5 plus 9, 145. Where do you get 125, guys? I prefer you use a calculator. Yeah, I prefer you use a calculator instead of trying to do it in your head. Oh, okay. So the whole region is A or B, okay? Not just 55 and 70. If you only consider 55 and 70, and you are talking about the set that include all the elements, all the respondents, only listen to one of the two types of music. Only listen to exactly one type of music. Only listen to classical or only listen to jazz. But we have 20 people who listen to both. When you consider A or B, okay, so this is about inclusive and exclusive. Do you guys did I talk about inclusive and inclusive? The or in this class, yeah, is the inclusive or. So when we say A or B, we means only A or only B or both. Yeah, we do consider both. Yeah, both are in the A or B. Is inclusive. You are welcome. So we do consider the 20 here, right? 70 plus 20 is 90. 90 plus 55 is 145. Also, just to know the region I'm framing, the whole region, that region like apple right now, right? The region represents A or B. That region represents A or B. Any elements in that region would be elements in A or B. All right. I think I make it clear. Be very careful. This is not exclusive or, it's inclusive or. Question number 5. How many respondents listen to classical but not jazz? What do you think? How many of them listen to classical but not jazz? Awesome. Perfect. Yes. 55. This time, the region representing people who listen to classical but not jazz is like a crescent moon, right? This is a crescent moon, right? Yeah. In A but not B. In classical but not jazz. Very good. Perfect. Number 8. Sorry, that's 6. Did I leave? Yeah, number 6. How many respondents listen to jazz but not classical? Listen to jazz but not classical. Perfect. I believe you have 70. Exactly. Awesome. 70 people only listen to jazz, not classical. All right, very good. Next part 7. How many respondents listen to neither classical nor jazz? They do not listen to neither of the two music. 30, right? How do you get is that typo again? Yeah. Is it 30? I believe it's 30 because we don't really see any numbers. It's 40. 30. This number 30 is inside the box, but outside the two circles. That's the cardinal number of this region. This region. If you want to see what does that mean, which region has 30 elements, 30 respondents. This region. Inside the box, but outside the two circles. In that region, we have 30 respondents. Those 30 respondents do not listen to either of the two music. So it's 30. Oh, okay. I understand. Yeah, it's okay. Thank you for your participants. Last one. How many people were surveyed? How many people were surveyed? That would be the cardinal number of the whole universal set, right? Yeah. How do you get that number found? 175. Perfect. Exactly. Just add all the numbers together, right? In this region, 55, this region, 20, this region, 70, outside the two circles, 30. So if we add them all together, that gives us the total number of respondents in a survey, the total number of elements in a box in the universal set. All right. So I think we understand how to we understand the information from a Venn diagram. But sometimes, let's say you do your own research, and you have to come up with your own Venn diagram. How do you do that? Let's look at the next problem. I'm gonna put a page breaker here. Okay. A survey of 250 memorabilia collectors. I've seen this word many times. It's just since I don't use them a lot, not very good at pronouncing it. A survey of 250 collectors showed the following results. 108 collected baseball cards, 92 collected comic books, 62 collected stamps. Furthermore, 29 collected baseball cards and comic books, 5 collected baseball cards and stamps, and 2 collected comic books and stamps. Finally, 2 collected all 3 types of collections. Create a Venn diagram to illustrate this. Well, our book gives us the structure, right? Since the problem involves 3 type of things. I apologize if you hear my daughter screaming. She's only 1 year old. She doesn't understand what mommy is doing here. And we try to, calm her down. Sometimes she screams very loud. Yeah, so the basic structure is right here. The box, of course, represents the Venn diagram, the universal set. And since the problem involves 3 types of things, baseball cards, comic books, and stamps, we need 3 circles, right? Yeah, the question actually gives us the 3 circles. Oh, thank you, Crystal. Appreciate that. And which one do you want it to be? Baseball cards? Which one you want to be comic books? Which one you want it to be stamps? To be honest, it really doesn't matter. But once you decide, you cannot change it. You have to keep consistency. How about let's use the one on the top, use the circle on the top to represent people who collect baseball cards. All right. So the subjects in this survey, the respondents in this survey, we consider what do they collect, right? Do they collect the baseball cards or comic books or stamps? 3 things. So this circle on the top, we use it to represent the set of respondents who collect baseball cards. And how about let's use the pink one on the bottom left to be the set of collectors who collected comic books. That's very cool, right? Some books that from a long time ago probably worth a lot of money, if you have the original version. And the bottom right, that circle represents the set of collectors who collected stamps. Yeah, stamps also very cool. I don't really know what is baseball cards, to be honest, because I don't know the sports much. Anyway, now we have labeled the 3 sets, right? Yeah, we know what the 3 sets represent, and we can start to fill in the cardinalities, like what we have seen today's class, right? The numbers are not elements; they are cardinalities of the regions. So let's go backwards, okay? Yeah, we start from 100A, collect the baseball cards, blah blah blah. But when we analyze, we want to go backwards. Let's start from two collectors collected all 3 types of memorabilia. So 2 collected all 3. 2 collected all 3. Maybe I can use colors. Probably want to use a very strong color because it already have some colors here. This region, again, is the center of the flower. This region is the common region of all the 3 sets. So that region represents the collectors who collect all the 3 types of memorabilia. And 2 of them, right? 2 people collect all the 3. So we have 2 here. And then we go backwards. Here it says 2 people collected comic books and stamps. Comic books, stamps, 2 people collected both of those 2. So this region supposed to be, this region I'm drawing, the football region, the overlapping part of the set of comic books and the set of stamps. That region is supposed to represent the collectors who collect both comic books and stamps, right? Based on the given information, 2 of them, there are 2 people collect both comic books and stamps. That means we should have 2 elements. We should have 2 elements in this football shape region. However, we have 2 people in the center. Does that mean we have 0 people in this region, in this paddle? What do you think? Yeah, that happens sometimes. The cardinal number of a region could be 0. That means that region is an empty set, right? That region represents the empty set. Please let me know, is that clear so far? The football region supposed to have 2 collectors, but we know the center has already 2 collectors, right? So that means this paddle should have 0 elements only. Perfect, very good. Yeah, that sometimes happens. It just only means there are no people, no collectors collect comic books and stamps only. Yeah, any collectors who collect comic books and stamps together also collect baseball cards. All right, let's go backwards. The previous sentence says 2 collected comic book. Okay, we do that already. And go backwards here. 5 collected baseball cards and stamps. Baseball cards and stamps. Baseball cards and stamps. Baseball cards and stamps. This region is the overlapping region of the set of baseball cards collectors and a set of stamps collectors, right? The overlapping region, this football region, represents the people who collected both baseball cards and the stamps. The question says there are 5 people. 5 people. So there are 5 people in the football shape region that I just highlighted. Does that mean we have 3 people here in a paddle? You know? So 2 here, then we need a 3 here in order to make a 5 in the overlapping region of football, baseball, and stamps, right? Do we agree, guys? Very good. Then let me challenge you a little bit. You're gonna tell me, you're gonna tell me how many elements in here. This paddle without the center, okay? Paddle without the center. I want you to help me to find out how many elements in that paddle. Hint, we need to use this piece of information. 29 collected both, 29 people collected baseball cards and the comic books. Baseball cards and the comic books. 29 of them. So how many people in that region that I highlighted? I have a question mark there. Would you help me to figure that out? Yeah. Take your time. Take your time. No rush. Awesome. Yes, it is 27. Correct. It is 27. Why is 27? Okay. Similar with earlier, right? It says, the question says 29 collected baseball cards and comic books. So we should have 29 people in this shaded region, in this red region, right? I highlighted the region, the football shape. 29 people, but we already have 2 people in the center. So 29 minus 2, 27. We have 27 in that paddle. Those 27 people, they collected baseball cards and the comic books, but not stamps. They only collect exactly 2 things. The 2 things are baseball cards and the comic books. Very good. We're making good progress, right? Yeah, we start from the center and then we go outside. We have more to go. Let's see what's the information before this piece. It says 62 collected stamps. Okay, 62 collected stamps. 62 collected stamps. Does that mean in this circle on the bottom right, I just highlighted, we should have 62 elements in it? In this circle, we should have 62 elements, right? Then how many, you know, in this region? How many in this region? How many there? $62. 50s. Do you have 57? Awesome. Very good. It is 57. Perfect. Because you want to make sure all the numbers, all those cardinalities representing those regions inside the circle add up to 62, right? You have a 0 here, 2 here, 3 here. Yeah, we don't have to worry about 0. So we already have 5 here. Then subtract 5 from 62, we have a 57. We have 57 in, in this region. We have 57 elements in that region. And that region represents collectors who only collected stamps. They only collect one type of thing. They only collect stamps. And it's very interesting, the graph, actually. When you start from the center, the center includes the collectors collect all the three. And the three petals represent the collectors who collect exactly two of the three things. Exactly two things. And then those three regions, this one, and this one, like an outer layer, yeah, we go from the center, right, and go outside. Those three regions represent the collectors who only collect exactly one thing, right? 57 only collect stamps. All right, we have two more to go. The information in front of that is 92 collected comic books. 92 comic books. 92 comic books. So we should have 92 elements in that circle, right? Then how many in this region? Like a pink, you know, the pink part inside the circle, how many are there? 92, 90, 90, 63. Do you have 63? Yeah, exactly. Perfect. You guys doing great. 63. Same idea, right? We need to make sure in the circle we have 92. We have 92. We already have 27 here, 2 here. That is 29. 29 plus 63, 82. 92, sorry, 92. Yeah. I actually encourage you use calculator. Sometimes I just, I supposed to use calculator, not misleading you. I do not recommend that you calculate in your head unless you're very confident and you do not make a mistake. I would encourage you to use a calculator to double check your answer, all right? So 63, oops, plus 2, plus 27, make sure they add up to 92, right? So the numbers match. One more. The first piece of information says 108 collect the baseball cards. Yeah, that means there are 108 elements in that circle. Then how many elements in this region, which represents the people who only collect the baseball cards? Yeah, let me do the math first. So 5, so that is 32, 6, 76. Do you have 76, guys? Yeah, awesome. 76, perfect. 76. We use the information that is given, but we go backwards, right? And we figure out all the cardinalities. Yeah, we figured out the cardinalities for all the regions. Now we are ready to answer the questions. Part A. How many collected comic books, but neither baseball nor stamps? So that means we're considering the people who only collect the comic books, right? Only collect comic books. So you need to do not guess. You need to use your pencil to find the region first. Collected comic books, but not the other two, right? How many collected comic books, but neither baseball cards nor stamps? And the region I'm highlighting right now, and that's, yeah, perfect. You guys great. 63. Based on the numbers we got earlier, we can easily answer the question, right? That's part A. Part B. Let me erase this. How many collected baseball cards and stamps, but not comic books? Okay, this time the respondents collected two types. Which two? Baseball cards and stamps, but not comic books. Okay, use your pencil, highlight the region. I'm gonna highlight the region, okay? Collected baseball cards and baseball cards and stamps, but not comic book. Collected baseball cards and stamps, right? So common region of this circle and this circle, but not comic books. So not those three. So do you agree, guys? What I highlighted the region, the paddle. This paddle represents the collectors who collect baseball cards and stamps only. Only 2 of them, not 3. So 3, right? Perfect. It's not or, Lexi. So let's look at it again. It says how many collected baseball cards and, yeah, sometimes it is a little confusing. Baseball cards and, not or. It says and. Yeah, look at the region I highlighted, the paddle here. That region represents baseball cards and stamps, but not comic books. Okay, perfect. So we should have 3 people, 3 collectors. And part C, how many collected baseball cards? Yeah, this time is a war, okay? How many collected baseball, this one, or stamps, but not comic? So yeah, there's 2 words difference. That's very different. This one is or, that one is and, this one is war. Okay, I'm gonna highlight, okay? Baseball cards or stamps, but not comic books. So the circle on the top, circle on the bottom right, but not circle on the left, bottom left. So that should be this region. Right? Yeah, weird shape. I couldn't figure out it look like what. Look like I don't know what look like. Funny thing. So 136, let's count it. So we have 76, so we have 3 here, 57 here, so that is 60. 60 times plus 7 is 130, 136. Very good. 136. That's correct. Thank you, Ashlyn. Perfect, perfect. And be aware the difference between part B and part C. Okay, there's only 1 word different, but it's very different. All right, so that's some warm up. Huh? Oh, sorry, my bad. We're not done yet. We have more. Sorry, let's finish this. I apologize. We have more parts, and I'm gonna move. Actually, erase the space. Only 3 more parts. Part D. How many collected exactly 2 types of memorabilia? Exactly 2. How many collected exactly 2? How many collected exactly 2? But we don't know which 2, right? Could it be exactly baseball cards and stamps, or exactly the 2 are comic books and stamps, or baseball cards and the comic books? Exactly 2. Find the region first. How many collected exactly 2 types of memorabilia? Look at the 3 paddles. Look at the 3 paddles. Those 3 paddles have collectors collected exactly 2. Those 27 collected baseball cards and comic books, but not stamps. 0 people here collected comic books, and stamps, but not baseball cards. 3 people here collected baseball cards and stamps, but not comic books, right? Do you agree? Those 3 regions represent collectors who collected exactly 2 types of the memorabilia. Yes, very good. So 30, right? So 30. You know, I really wanna, I need to emphasize this thing. So give me like 2 minutes. I need to show you what I'm trying to say. Draw a better circle, circle, circle. Okay. Redo this one. All right. So this is A, B, C. I'm gonna use a different color to shade the region. Okay, this is U, universal set. Pink, yellow, yellow, yellow. Green, 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 and then one more color. Let's do blue. Okay, so I wanna use 4 different colors to color the regions in this Venn diagram, and I want to show you the pink color. The pink color. So we have 3 different colors, right? Pink, yellow. Yeah, put a legend here. Green and blue. So the pink color region includes collectors who collect exactly 3 types of memorabilia. All the 3. So exactly 3. Exactly 3. In other words, the pink region has elements belong to exactly 3 sets, belong to A and B and C. Exactly 3 sets belong to exactly 3 sets, A, B, C. And the yellow region, the 3 petals, those regions together include all the elements belong to exactly 2 sets, right? This petal elements in this petal belong to A and B, but not C. This one's A and C, not B. This one's B and C, not A. But together, those 3 yellow regions, they include all the elements belong to exactly 2 sets. The green region, yeah, we could start from the center and go outside, right? Go out from the center and then expanding to the outside. The green region includes all the elements belong to exactly 1 set. Exactly 1 set. And this region elements only belong to A, not B or C, only belong to A. This part only belong to B. And the elements in this part only belong to C, exactly 1. And the blue region, outside the 3 circles, inside the universal set, those elements belong to exactly, not 4, 0. Yeah, 3, 2, 1, 0. Belong to none, right? Belong to neither, none of the 3 sets. So I just want to show you this. It's pretty interesting. Exactly 3, exactly 2, exactly 1, exactly 0, right? I just want to see you, then show you this, then you can understand it better. Does that make sense, everybody? Would the colors actually help? Very good. Thank you for your response. Almost done. Okay, we have 2 more. Part E. How many collected at least one type of memorabilia? At least one. At least one. At least one include exactly 1, exactly 2, exactly 3. Okay. Exactly, at least 1. Another way to describe that set is A or B or C, right? At least 1. Do you agree this region represents at least 1? This region represents at least 1, right? You just need to add all of them together. So let me quickly, what do we have here? 16. That is 90, so it's 150. A 228. Do you have the same number? Awesome. Thank you, Levin. Exactly. 228. At least 1. A or B or C. Last part. How many? Yes, exactly. Thank you, Ashlyn. Same with our answer. Last one. How many collected none of the 3 types of memorabilia? None of them. How many? So earlier we know at least 1. So the people who collect at least 1 is 228. And the question tells us the total number of people responded to the survey is 250. Do we need to use 250 to minus 228, which gives 22? Yeah, actually you can put a 22 here, right? To represent the number of people who collected none of the 3 things. Yeah. Just like this, right? The people who fall in the blue region, they collect none. They collect none. And we just need to use the total number of people, 250, to minus the number of people who collected at least 1. This is this region, which has 228 elements. The difference would be the number of elements in the blue region. And we finished. Any questions, everybody? Any questions? Thank you. When you work on problems, either your homework assignments or your quizzes or tests or reviews, when the problem has a lot of words going on, you really should take your time to read those words. And a lot of details doesn't matter. Perfect. And we are going to talk about 2 problems in MyLab Math. Let me get it, MyLab Math here. One of the questions, I already posted a video in Blackboard, is 2.5, section 2.5, number 16. But that is just a, let me see. I don't remember in the video, do I have both cases? Yeah, the problem actually have 2 cases. I'm going to talk about the case. This is 1 p.m. class. Let's see what case I would get. Because the numbers are randomly generated by the system, sometimes I get a case A, sometimes I get a case B. I'm talking about section 2.5, question number 16. This problem. Yeah, sometimes you have to choose A, sometimes you have to choose B. I'm not sure about C. Let me get this. I'm going to use my OneNote. Yeah, this Venn diagram on the right, top right. It also has three circles representing set A, B, and C, and we have 8 regions. They use the Roman numerals to represent the regions. Region 1, 2, 3, 4, 5, 6, 7, 8. 8 regions. Those 8 regions are disjoint. None of them have any overlapping part with the other. So they are all disjoint. Together, they make the whole universal set. So those are the 8 regions. And we also are given some information that those numbers are randomly generated. That's why sometimes you choose A, sometimes you choose B. In my case, the question I get here, we have the universal set contains 39 elements. A has 18 elements. B has 8 elements. C has 18. A and B has 5. A and C has 7. B and C has 4. A and B and C has 2. So does that mean in the middle, the center of the flower, we have 2 elements here? We have 2 elements in the region 5. Okay, I can actually write this way. There are 2 elements in region 5. Let me quickly see which case this is. A and B is 5, so that's 3. A and C has 7, so that is 5. 5, 10. A is, okay, actually this one belongs to the case A probably. Okay, region 5 has 2 elements. Anybody can help me to figure out how many elements in region 2. But I can remind you, this football region is the common region of A and B. A and B, so there are 5 elements. So if you have 2 elements in the center, in the paddle, region 2, in the paddle, we should have 3 elements. Do you agree? Guys, do you agree, everybody? If not, let me know. Region 2 and region 5, region 2 and region 5 together has 5 elements. That is given because that's the intersection of A and B, right? I need to see your, yep, very good, very good. So now we have some cardinal number found. And then look at it here, A and C. A and C have common elements 7. Yeah, 7 common elements. Set A and set C has common element, has 7 common elements. But we already have 2 in the center, so we should have 5 in region 4. Region 4 has 5, region 5 has 2. Together make 7. The number matches. All right, very similar with earlier. And this region, football shape, is the overlapping part of B and C, and is a region V and region 5 and region 6. In this region, we should have 4 elements, right? 4 elements. Since in the center we have 2 elements, we should have 2 elements in region 6, this paddle. All right? Yeah, this one I haven't got a number. We get an 8. I have a video about this, but sometimes you got a B or C, right? This one doesn't apply. If we don't have time to cover this, I'll try next time just to quickly show you how do we How do we know it's impossible? But this one is the case that it is possible. Okay, so keep going. And region 1. In circle A, we have 18 elements, right? In circle A, we have 18 elements. We just need to use the 18 elements to minus the number of elements in region 2, number of elements in region 4, and number of elements in region 5. So we have 18 minus cardinality of region 2 minus cardinality of region 5 minus cardinality of region 4. And that gives us, so region 5 has 2 elements, region 2 has 3 elements, region 4 has 5 elements, so it's 10 elements, 8 elements. So region 1 has 8 elements. And similarly, you can find region 3 and region 7. I'm not going to continue because I have a video in Blackboard. Let me show you quickly. Watch the video. Section 2.5, number 16, right? And that's the case when it's possible. I wanted to do the case that is not possible, but it doesn't give me the case. But it's okay. We maybe figure it out next time. All right, so I'm going to show you another question. Number is the country. Yeah, this one. I'm going to talk about this problem. The last 5 minutes, let's talk about this problem, or at least to get it started, and you understand how to process this. In previous semesters, those 2 problems are the problems students asked. Every semester, students ask the 2 problems. So I don't want you to struggle or suffer. You want to watch the video or take notes when we look at it together. All right, let's see this survey problem. The box is universal set. Circle A, I can actually color it. Color yellow. The yellow region, the yellow circle, country A. People in this set are from country A. Blue. People in the second circle on the right, they agree, as you can see, is labeled as agree, right? They agree what? They agree with a statement. The content of the statement really doesn't matter for our problem. We only consider how many people who agree or disagree, right? So the circle on the right, they include people who agree with the statement. A survey was taken that asked 1,090 randomly selected adults from country A and country B to agree or disagree with the following statement. And the results are summarized in the Venn diagram. So the region 2, the green region, yellow with blue is green, right? The green region is the overlapping part. That means the people in that region, in that set, are from country A, also agree with the statement, right? Okay, one more color. I want to use probably purple. This region, inside the box, but outside the 2 circles, that's the purple region, or region 4. They include the people who they do not belong to any of the 2 circles, right? Means they are from country B and disagree. So I want to show you, I want to write this down. Then when you work on the problem, you can would actually make your job a lot easier. So you want to write it down. Region 1 includes subjects from country A who disagree. Oops, sorry. Who disagree. Because it's not in the blue circle, right? Blue circle are people who agree. So since region 1 is outside the blue circle, they do not agree, they disagree. And region 2 are from country A. Yeah, they are country A people who agree, right? Because they are the overlapping part of the two sets. And region 3 represent the people from country B who agree. Because region 3 include is in the blue circle, but not in the yellow circle. So region 3 represent people who from country B and agree inside the blue, so agree. And region 4, the purple region, are from country B disagree. Right? So I want you to write this down because we are running out of time. If you write it down, when you look at the who is raising hands, right? Anybody is raising hands? I missed it. Jessica? Is anybody raised the hand? All right. So I was saying that. Okay. So I was saying write this down. It will help you to understand the problem. Will make your job a lot easier when you work on the problem. All right. Since we ran out of time, we're going to stop here. Essential class, I'll see you in 10 minutes. And other students, I will see you on Monday. Do not forget you have assignments due. Do not forget you have assignments due in 3 days, 2 days, yeah, the last day of the month. All right. Okay. See you guys. Bye-bye.
Bye.